couple of other important examples. Here we have a really important map from 1854. This was cholera. Cholera is related to water. You get it from contaminated water, and this is part of London, Oxford Street, Regent Street, Piccadilly, and there was a cholera outbreak near a contaminated pump. The important thing was that John Snow worked out which pump it was by mapping all of the deaths from cholera. He looked at the deaths and then he placed the pumps on the same map, and he worked out that basically all of the deaths seemed to be happening around a particular pump. He showed this to the council, and they stopped the pump from working and stopped the cholera outbreak. Notice there's all these other pumps and none of them were contaminated, so there's hardly any deaths near them. But this pump had heaps of deaths all around it. This is another famous example by Charles Minard. This is in the Tufti book, the Visual Display of Quantitative Information, and this represents Napoleon's invasion of Russia, ill-fated, as you can see. Now this is a very interesting map because it contains lots of information. The width of the line is the number of soldiers in Napoleon's army. The colour is whether they were advancing towards Moscow or retreating, black being retreating. The temperature here is listed as well, as is the so you can see the temperature here, -9, etc., and you can see the altitude as well. The degrees are actually here, so it's backwards. You get down to colder and colder temperatures. You can also see rivers here. You see there's a river, and you can see there was a number of people, number of soldiers, and as they crossed the river they lost a huge proportion. So rivers were extremely dangerous to soldiers in the 19th century. Here's another important part. This is a secondary force that retreated early, probably luckily. Basically you can see that when Napoleon returned to France, there was no one left. And that was the end of Napoleon's attempt to take over Russia. Now this example is really interesting for lots of reasons. This is Ben Fry's zip decode. It's quite an old example now, but it's really interesting. So I'll show you this one. So this example is of an interactive system. In this case, what Ben Fry does is he allows you to look at all of the zip codes in the USA by typing in values. So you can type in 9 to start with, and you'll see all of the zip codes and their locations for zip codes that start with 9. And then you can continue to type numbers, and you'll see 90 is one particular place, LA. 99 is over there. 98. 98 is there. 997. 96. Whoops. 95. 94. 93. 92. 91. 90210 is Beverly Hills, California. So this is the display of data in an interactive format. Just by looking at any of these, you can't get much of the information that's necessary, but by interacting with the data, you can interact with a huge array of information and see it visually displayed to you. So interaction is essential to this display. In the last couple, there's no interaction. We just read. We need to understand the way that data is represented. But with modern computer-based systems, we do need to interact often to get the data, and that's critical. Heat maps are a form of map that is based on color, and you can see heat maps quite a lot in various places. Here's a good example of a heat map used for an interesting type of thing, where here we're looking at eye tracking data for an advertisement. An advertisement is put in front of someone, and we track the eyes and look where they're looking and focus on try and understand what parts of the advertisement are working well. So if you notice, most of the eyes are looking at the baby's face. That's pretty clear. And that's not surprising, because eyes and faces are linked very close. We have a whole part of our brain that is set up to just look at faces and recognize faces. Then we can see extra gentle for the most sensitive skin. Extra gentle seem to have quite a lot, and then we start reading the first part here, but people don't seem to read much more. There's not much time devoted to this last sentence at all. Most of the effort is placed on this first part here. This logo down the bottom right hand corner seems to get quite a lot as well. So this is a heat map. It's a matrix of data. We have the amount of time spent on each portion of the screen broken up into X and Y values. So a well-known data visualization or information visualization mantra, that's what it's called, the information visualization mantra, was written by Ben Schneiderman. His information visualization mantra was overview, zoom, and filter with details on demand. So firstly, you want to see an overview of the entire collection of data. You want to get a feel for the whole lot. You want to understand everything there. Then you zoom in on items of interest, or you filter out uninteresting items. So you throw away stuff that isn't useful, or you zoom in on a particular portion. That's two different ways of actually throwing away uninteresting stuff. And then you want details on demand. You want to be able to go, okay, this thing here looks like it's in a really important position, but what is it? What's the details of it? How did it get there? So we start wide with an overview, zoom in on particular items, and get details on demand. So that's what's going on with zip decode, because we can start to see the whole US. We can choose a particular postcode, well, a range of postcodes, and see where they're located generally, and then we can zoom in further and further and further and see their particular name for each and every postcode. So what are you trying to do? You want to relate relationships among items. You want to see comparisons between things. You want to keep a history of actions to support undo, and you also want to allow extraction of sub-collections and of the details when needed. So relationships, comparisons between groups are really important. So that's another form of relationship. And extracting subsets of data is really critical as well. So here's a good example of a system that you can play with to understand how meteorites have landed throughout history and where. So have a look at this link. you've already seen the dumpster, but that's another really good example of overviews, zooms, and filters. And finally, this is a good example of budgets. We can try and go to this one if you like. So this is an example. Here's a bit of context. The schools that spend the most money on men's basketball, and you can see as soon as we mouse over things, we can see the different parts of the data. And who wins. So you can follow Wichita State through the system, 4 million. There we go, all the way through to there, etc. You can also change the format of the data relatively easily and see data in lots of different ways. Another example of interaction is this system for looking at wealth and comparing it with train lines. So here we have an interactive system that tells you about the wealth of the places you pass through on particular train lines in New York. So some principles. Each project has unique requirements, and a visualization should convey the unique properties of the dataset it represents. Often less detail will actually convey more information because the inclusion of overly specific details causes the viewer to miss what's most important or disregard the image entirely because it's too complex. So the first one there, each project has unique requirements, is critical. You need to understand your data to visualize it, and that's really difficult. It takes time. Just mapping something to something else does not a visualization make. It just makes some kind of image. To actually give access to the meaning of the visualization requires a complex set of design decisions to be executed well. The second quote, less detail will actually convey more information. That's true in most circumstances. Often seeing lots of data but not seeing the average doesn't show you what is going on with the data. So sometimes you need to zoom and filter and then provide details on demand. If you just provide loads and loads of details, you can't see what's going on. You also need to provide the overview. You also need to know your audience. What are their goals when approaching a visualization, and what do they stand to learn? So you need to think of your visualization as the answer to a question, but what's the question? If you don't even know what the question is, it's going to be really difficult to work out what the visualization should emphasize and focus on. So here's a little link to a system called Twitter4j, which is well established now. This is a method for accessing Twitter from Java. Now, most of these systems that have an API, like the Twitter API, will require you to sign up to Twitter's development system. So you get a key, you get a special identification key that allows you to access the data. And also you have a limit. You can't just access it every second, all day, every day. You can only make a certain number of calls per day, but usually it's plenty. So to get this system up and running, you need to do two things. You need to work out the software on your end, but you also need to sign up for access at the Twitter end as well. Here's some other sources of data, but there's lots and lots of sources of data, and there's one obvious source of data is the system that we have here at UTS for accessing the data in the building. A couple of interesting systems. There's a interactive data visualization with processing course on lynda.com, and there's Visualizing Data by O'Reilly Media. Some other really interesting books are all of the Edward Tufte books, which were at the start of the set of slides, and another really interesting book is called Exploratory Data Analysis by not Tufte, another T. His name is I want to say Turing, but it's not Turing, it's Tukey. Yes, John Tukey, T-U-K-E-Y. So John Tukey was a statistician who came up with a lot of the really important statistical procedures in around the 60s. This is an old book, but it's still a really interesting book, and it's worth delving into. It's called Exploratory Data Analysis, and it's pretty easy to find. All at the library. All right, thank you very much.